Today, if we calculate the amount of fresh water that is unsuitable for drinking,
And also disgusting.
that's right, Betsy. So if we calculate the volume of this dirty water, it's simply disheartening. If humanity doesn't come to their senses to protect their fresh water resources by taking preventive measures and cleaning and treating wastewater,
Then in the nearest future, there will be no one to treat them. This is why the role of a wastewater treatment specialist is the most important job in the world today.
well done, Betsy. You understand everything right. Perhaps I should test you?
Okay, sir, I'm ready.
Okay, let's go through the sections.
I know this topic quite well. I'm ready for your questions, Professor Higgins.
No, let's try something else. I will be the student, and you, Professor Betsy Doolittle, will teach me what you have learned so far.
We, as wastewater treatment specialists, may I call us wastewater treatment specialists?
Yes, go on.
Thank you, Professor. Today, wastewater treatment specialists are like doctors trying to treat the constantly appearing numerous unknown diseases because the amount of new pollutants which pass daily into our wastewaters is tremendous.
Furthermore, some of the pollutants, which are often very toxic, can pass untreated through wastewater treatment plants and end up in our lakes, ponds and rivers. For now, we'll focus on the four most common sources of pollution. The first one is household detergents. Substances with a longer decay rate, such as detergents and plastic products, are more damaging. Bodies of water turn into swarms, where is a decrease in the amount of dissolved oxygen, and as a consequence, fish start to die and the whole water biodiversity sharply decreases. Moreover, the toxic compounds start accumulating in living organisms in this polluted water through trophic chains.
It should also be kept in mind that these toxic compounds accumulate in the sediments of the body of water.
Which results in secondary pollution. I remember, sir.
Very good. Go on.
The second source of pollution is industrial emissions generated by incineration plants, thermal power plants, and petrochemical companies. Fumes from these industries end up saturating the air above the cities with pyrens, dioxins, benzenes, and other high toxic compounds.
Betsy, don't forget cars and other transport. They discharge much more carcinogens and mutagens into the atmosphere than all the factory chimneys combined.
Exactly. So when it rains, the rain brings the air pollutants into the bodies of water. Do I need to explain how polluted the water becomes and what happens to the hydrobionts?
I think it's quite clear. Go on.
The third source of pollution is the use of pesticides in farming. Rainwater washes the chemical compounds into surface runoff and groundwater. From there, some amount of pesticides inevitably enter into our food chain. In 2001, the Stockholm Conference published a list of the most hazardous pesticides and called for a ban on their usage. However, pesticides are still widely used and the resulting pollution of the soil and waterways is very high.
I have nothing to add, Betsy. Go on.
Okay. And finally, the fourth source of pollution, the newest one, is pharmaceuticals, consumed globally by humans. Chemically unchanged, they pass through the human metabolism and are released to the environment. Conventional treatment methods are not sufficient for the removal of numerous pharmaceuticals and often require modern treatment methods, but even then, complete removal is not guaranteed. In the same way, pharmaceuticals consumed by animals and birds get released into the soil and water bodies. Moreover, antibiotics used in the fish farms are released to the environment without any treatment. This not only affects other flora and fauna in the environment, but also the fish and the humans consuming them, which is horrible.
I agree. Is that all?
Overall, yes.
In which case, Betsy, I'm afraid you've missed one of my lectures. The fifth, not the most poisonous, but the most widespread cause of water pollution is...
Domestic wastewater. I didn't miss any of your lectures, Professor Higgins.
I'm flattered. Then tell me, why exactly are domestic wastewaters so hazardous for the environment?
Despite the low toxicity, domestic wastewaters have a high nutrient content, which is the main cause of algal bloom in bodies of water.
The main cause of eutrophication. Let's remember the term.
Okay, domestic wastewater is the main cause of eutrophication and secondary pollution of bodies of water. Moreover, many treatment facilities don't meet the standards of modern water treatment. Some of them require modification or complete reconstruction, but there is more to it. Almost everywhere, especially in rural areas, domestic wastewaters flow directly into lakes, ponds and rivers, spreading pollutants, pathogens and bad smells. What's more astonishing is that this even happens in well-developed first world countries, where domestic wastewaters drain unfiltered into seas and oceans. Therefore, we, as wastewater treatment specialists...
Betsy, please, less drama. Let's illustrate this horrible scenario through a simple example, shall we?
I'm sorry, Professor. I'm not being dramatic, but that type of irresponsible behavior makes me angry.
I understand, but let's solve the problem.
Okay, sir. I'm ready to start.
Imagine a crystal clear enclosed mountain lake.
The volume of water in the lake is fixed and makes up 1 million cubic meters. On the shores of the lake is a small village whose population is 1,000 residents. In 24 hours, each resident produces about 8 grams of ammonium nitrogen, which enters the domestic wastewaters. The domestic wastewaters flow directly into the lake without any treatment.
One moment, Professor.
Okay.
How terrible! The fish start dying in 50 days. It takes just 50 days. Making something useful requires knowledge and hard work, while this requires no effort at all.
Well done, Betsy, you're doing well. But don't worry, we've missed something in the problem. Do you know what it is?
I'm not sure, sir. All my calculations are technically...
Finally, there is something you don't know. Take a seat, please. I'll remind you what you've missed. All natural bodies of water have an important regenerative quality called self-purification. The bodies of water, which are not subjected to incremental pollution load, can purify themselves to maintain their ecological balance. Now, can you define the self-purification in relation to bodies of water?
It's a process where the water bodies regenerate themselves by decreasing the pollutant load over a certain period of time.
Overall, you're right. However, it should be noted that natural self-purification occurs without any help and human intervention. Let's take, for example, the self-purification of a polluted river. Here is a cross-section of the upstream part of the river.
Let's call it point A, and here is the one downstream, point B. Let's assume that there is a constant flow of industrial wastewater and the higher upstream section of the river. We need to discern what amount of grams per square meter of pollutant enters at point A and what amount of remains at point B, and then calculate the difference between the top and bottom sections. That way we can measure the difference in pollutant concentration at point A and point B. This is the indicator of self-purification of the river in that section.
Professor, so what does a negative difference in the concentration signify?
It means there is pollution that is unaccounted for. And you and I, Betsy Doolittle, as wastewater treatment specialist, have to find this additional source of pollution. In this regard, Betsy, I have a question for you. What should be done when a natural body of water fails to withstand pollution?
Clearly, we have to build treatment facilities.
Okay, so what kind of wastewater treatment do you suggest to clean this imaginary river?
There are two main types of treatment facilities depending on their methods. The first facilities use physical-chemical methods, sorption, flotation, reverse osmosis, etc. While the other treatment facilities implement a biological technology.
You are absolutely right. We will use the second option to treat our imaginary river. However, only on one condition.
I know! We need to make sure that the additional pollutant in the river stream isn't fatally toxic for the hydrobiomes of the second type of the treatment facility.
And then, our treatment facility of the second type, replicating the processes of the self-cleaning of rivers in a much smaller volume, becomes a part of the river ecosystem and helps the river to restore its cleanliness. We use the same formulas to calculate the performance efficiency of the treatment facility and self-purification efficiency of the river. In other words, for every pollutant, removal efficiency expressed in percents is equal to the ratio of the difference of the initial and the final concentrations to the initial concentration.
But Professor, you told us that the concentration of pollutants changes throughout the day, both at the entrance and exit of the treatment facility. Should we take that into account?
Not at all. Remember how we calculated the treatment efficiency by taking the average daily values of influent and effluent pollutant concentrations. Treatment facilities measure them hourly. Such frequent and accurate measurements help to calculate the total amount of daily influent and effluent pollutants. Thus, we can quantify the pollution load in kilograms per day using the formula which sums the product of C by Q, where C is pollutant concentration and Q is water flow rate. C and Q are measurements taken every hour during the day.
Betsy, do you have any questions?
No, Professor, everything is clear, thank you.
Well, if everything is clear, please open the workbook and solve the problem. Section 1, episode 2, please.
I think it's related to the material we just discussed.
Correct? Please read the problem conditions out loud.
Use the following table of hourly measurements of pollutant concentrations and synchronized measurements of the rate of the flow of water. Calculate the total pollutant concentration load received per day and then calculate the efficiency of its purification from the pollutant as a percentage. I have no questions. We will use the same formulas.
Keep in mind that we are using a biological treatment facility.
I remember, sir.
The organic substance removal efficiency is approximate 97%.
Excellent. However, Betsy, you understand that such efficiency can only be achieved by removing oxidized organic matter. Moreover, the concentration of substances is characterized by an indicator of biochemical oxygen demand, that is BOD, as we, wastewater treatment specialists, say. And all this has something to do with water retention time at the treatment facility. Now please, tell me exactly how this is related.
The water retention time is, I think this is...
Water retention time at the treatment facility is a term signifying the time period during which water and purification facility is completely renewed.
Yes, I remember we made calculations of hydraulic retention time for different treatment facilities of various volumes during the seminars.
Indeed. Betsy, let's solve the following problem on the board to get a better understanding.
Okay, I'm ready.
Good. Give me the workbook. Let's use the same facility we just used to calculate daily pollution load. By the way, this type of treatment system is called constructed wetlands.
This treatment wetland is a continuous system with a volume of 1,500 cubic meters. The incoming flow rate is 300 cubic meters per day. What is the hydraulic retention time for this wetland? Is the question clear, Betsy?
Yes, the formula is simple.
I see you've managed the task. So what are your results?
The water retention time for a treatment wetland is 5 days. Isn't that a bit too long, Professor?
I have to remind you, Betsy, that you were calculating for a constructed wetland. 5 days for this type of treatment facility is normal. The values of hydraulic retention time can vary from 3 to 8 days depending upon the type of constructed wetlands. Also, keep in mind that there is a huge variety of wetlands, but
But we haven't covered it, Professor.
if we haven't covered this yet, we will go over it in our next lesson, dedicated to constructed wetlands classification. Betsy, could you please write on the board 4 types of constructed wetlands? Goodbye, Miss Doolittle.
Have a good evening, Professor.